This video is for Chapter 9, Testing a Claim, and starts off with Section 9.1 on significance tests, the basics. So we're going to talk about first what is a significance test. And so that's a formal procedure for comparing observed data with a claim or hypothesis whose truth we want to assess. So basically it will be like having some sort of situation and we want to test if some sort of treatment that we're imposing or some sort of experiment that we are doing is going to have some sort of effect. So a null hypothesis goes right along with that, and so the claim tested by an S statistical test labeled H sub 0 or H0, and that means that the test is designed to assess the strength of the evidence against the null hypothesis, and often the null hypothesis is a statement of no difference. So this basically means that nothing changes whenever we do whatever it is we're doing in our test. The alternative hypothesis is kind of the opposite of the null hypothesis, so the claim about the population we are trying to find evidence for, so saying that there is some sort of difference based on what we did to our situation, and we label that H sub A or HA. So I think the best way to start with this one is just to kind of look at an example and see what's happening, because I think it will make some more sense whenever you're seeing an example. So, does the job satisfaction of assembly line workers differ when their work is machine-paced rather than self-paced? One study chose 18 subjects at random from a company with over 200 workers who assembled electronic devices. Half of the workers were assigned at random to each of two groups. Both groups did similar assembly work, but one group was allowed to pace themselves, while the other group used an assembly line that moved at a fixed pace. After 2 weeks, all the workers took a test of job satisfaction. Then they switched work setups and took the test again after 2 more weeks. So hopefully you've kind of recognized that this is a matched pairs design that we talked about back in Chapter 4. If you did not, you might want to go back and review matched pairs design. So the response variable is the difference in the satisfaction scores, the self-paced minus the machine-paced. So they tell you this part right here is self-paced minus the machine-paced because that's going to be important to you for the whole rest of everything that you're doing. So the first question is ask you to do describing the parameter of interest. And so the parameter of interest for this particular problem is the mean or the mu of the differences, the self-paced minus the machine-paced, that came from right here, and the job satisfaction scores in the population of all assembly line workers at this company. So basically the question is, was there a change in the job satisfaction of those that were self-paced minus those that were machine-paced? The next question says, state appropriate hypotheses for performing a significance test. All right, so because the initial question asked whether job satisfaction differed, the alternative hypothesis is two-sided. So either your difference in the job satisfaction scores is less than 0 or the difference is greater than 0. So basically, your HA, your alternative hypothesis, is going to mean that there's some sort of change. So either the difference was less than 0 or the difference was greater than 0. And a lot of times whenever you see a situation like this where you have a less than a 0 and a greater than a 0, that would mean that your mean was not equal to 0. So either it's below it or it's above it, but it's not equal to it. So that would mean that our alternative hypothesis meant that our mean was not equal to 0. And remember that our null hypothesis means that our mean is equal to 0. So these are our two that we're looking at. So either your mean is not equal to 0 or your mean is equal to 0. Not equal to is your alternative hypothesis. Equal to 0 is your null hypothesis. So next we're going to talk about a one-sided alternative hypothesis. So one-sided alternative hypothesis states that the parameter is larger than or smaller than the null hypothesis value, but not both. So that would either mean that your mu was less than 0 or your mu was greater than 0, but it couldn't be both like the last one was. Two-sided alternative hypothesis states that the parameter is simply different from the null hypothesis value, so it's either larger or smaller. So this one is not both this one could be both. It could be either one. So your mean is less than 0 or your mean is greater than 0. Either or. All right, so let's look at check your understanding. So for each of the following settings, A, describe the parameter of interest, and B, state the hypotheses for significance tests. So basically just like what we just did in the last example. So number 1, it says, according to the website sleepdeprivation.com, 85% of teens are getting less than 8 hours of sleep a night. Janie wonders whether this result holds in her large high school. She asks a simple random sample of 100 students at the school how much sleep they get on a typical night. In all, 75% of the respondents said less than 8 hours. So for A, it asks us to tell what our parameter of interest is. So for 1A, our parameter of interest is going to be P, which is the proportion of students at Janie's high school who get less than.
Attention, please, everyone. At this time, all students should be in their first period class. We'll be in there for a brief time, and then we will transition to lunch in the second period. Ms. Massimino is currently making her way through the building. We do have some scores that are back from yesterday, so it's quite possible that some of you will be informed of what you made on your test as you report to first and second period today. So she's working her way through the building to deliver those at this time and should be there shortly. Sit tight and we'll let you know that it is time to transition to second period and lunch. Thank you.
For A, on number 1, we need to state what the parameter is. So if we're stating what the parameter is, for this case it's going to be P, and so P would be equal to the proportion of the students at Janie's high school who get less than 8 hours of sleep. All right, B says state the appropriate hypotheses for a significance test. All right, so we have to state what H0 would be, and we also have to state what HA would be. So H0 is going to mean that there's no change from what we see on the website. So the website said 85% of the teens are getting less than 8 hours of sleep, and so if we're looking at our null hypothesis, that would mean that our P for what we're looking at, our test, would be exactly the same as the P up here. So P would be equal to 0.85. No change. The alternative hypothesis just means that our P is going to be different from this 85%. So it's just not equal to 0.85. It can be bigger, it can be smaller, but it cannot be 0.85. All right, number 2. As part of its 2010 census marketing campaign, the U.S. Census Bureau advertised 10 questions, 10 minutes, that's all it takes. On the census form itself, we read the U.S. Census Bureau estimates that for the average household, this form will take about 10 minutes to complete, including the time for reviewing the instructions and answers. We suspect that the actual time it takes to complete the form may be longer than advertised. So for 2A, we have to state the parameter of interest. And so for A on this one, we're going to use the mean. So the mean mu would be the mean amount of time that it takes to complete the census form. All right, so if you'll notice, our parameter that we used for the first one was the proportion of students who got less than 8 hours of sleep. The second one was the mean. So the reason that they changed is because our situation was completely different. We were looking at actual numbers of people here, and in this question, we're not looking at actual numbers of people. We're looking at the amount of time, and that amount of time is going to be an average or the mean. So then for B, we have to state our null hypothesis and our alternative hypothesis. So our null hypothesis means that there's no change from what they said in the situation. So the null hypothesis would mean that the mean or the average would be equal to 10. But in here it says that we suspect that the actual time it takes to complete the form may be longer than advertised. So if we think that it's going to be longer than advertised, then our mean would be greater than the 10 minutes that they said. All right, next we're going to talk about a p-value. So a p-value is the probability that the statistics would take a value as extreme as or more extreme than the one actually observed. The smaller the p-value, the stronger the evidence against H0 provided by the data, or the null hypothesis provided by the data. So we're going to go back to our job satisfaction and interpret a p-value for this problem. So for the job satisfaction study described on page 531 that we've already talked about, the hypotheses are the null hypothesis means that the mean is equal to 0, and the alternative hypothesis means the mean is not equal to 0. So either the mean is less than 0 or the mean is greater than 0. And remember that the mean is the mu is the mean difference in the job satisfaction scores, the self-paced minus the machine-paced, in the population of assembly workers at the company. Data from the 18 workers gave x bar equal to 17 and s sub x equal to 60. So the mean 17, the standard deviation 60. That is, these workers rated the self-paced environment on average 17 points higher. The problem says researchers performed a significance test using the sample data and obtained a p-value of 0.2302. Explain what it means for the null hypothesis to be true in this setting. All right, so for A, if the null hypothesis is true in this setting, then that means that the mean difference in the satisfaction scores, the self-paced minus the machine-paced, for the entire population of assembly workers at the company is 0. So I'm going to type all that out because that's a lot. So it means the mean difference in the satisfaction if H sub 0 is true, then the workers don't favor one work environment over the other on average. So if h sub 0 is true, the mean would be equal to 0, which would mean that there was no difference in the self-paced minus the machine-paced. So it seems like everybody kind of likes both environments equally. All right, so then B. All right, for B, it says interpret the p-value in context. So the problem tells us that our p-value is 0.2302. Well, that p-value is the probability of observing a sample result as extreme or more extreme in the direction specified by the alternative hypothesis just by chance when the null hypothesis is actually true. So basically, it's the probability that the null hypothesis happens by chance. And so this is 23%. And I know that because I can jump that over, I get 23%. Okay, so up here, we talked about how the null hypothesis meant that the mean mu was equal to 0. Remember that the mean is the population mean. And so the population mean for the entire company would be equal to 0, with the mean being the difference in the job satisfaction scores, the self-paced minus the machine-paced. The alternative hypothesis is when the mean mu is not equal to 0. So either the mu is greater than 0 or the mu is less than 0. In this case, we're talking about how x bar, the sample mean, was 17. And so that would fall into the category when the mean was greater than 0. And so we are trying to say that for your p-value, you would interpret it by saying an average difference of 17 points. Actually, it's really 17 or more points between the two work environments would happen 23% of the time just by chance in random samples of 18 assembly line workers. So then in part C, it says, do the data provide convincing evidence against the null hypothesis? All right, so remember that our p-value was 23%. And so because 23% is kind of a small value, really, then we would say an outcome that would occur so often just by chance, in this case, almost 1 in every 4 samples of 18 workers, 23%, almost 25%, when the null hypothesis is true, is not convincing enough evidence against the null hypothesis. So basically, the conclusion of the job satisfaction study is not that the null hypothesis is true. The study looked for evidence against the null hypothesis, basically when the population mean was equal to 0, and failed to find strong evidence. That is all we can say. Failing to find evidence against the null hypothesis means that the data are consistent with the null hypothesis, not that we have clear evidence that the null hypothesis is true. All right, so let's talk about statistically significant. So when the p-value is smaller than a set value, alpha, which we represent, it kind of looks like a fish. In that case, we reject the null hypothesis and conclude that there is convincing evidence in favor of the alternative hypothesis. So a company has developed a new deluxe AAA battery that is supposed to last longer than its regular AAA battery. However, these new batteries are more expensive to produce, so the company would like to be convinced that they really do last longer. Based on years of experience, the company knows that regular AAA batteries last for 30 hours for continuous use on average. The company selects a simple random sample of 15 new batteries and uses them continuously until they are completely drained. A significance test is performed using the hypotheses, where the null hypothesis, the population mean, is equal to 30, and the alternative hypothesis is when the population mean is greater than 30, where mu is the true mean lifetime of the new deluxe AAA batteries. The resulting p-value is 0.0276. What conclusion would you make for each of the following significance levels and justify your answer? All right, so anytime that you're looking at an alpha, which is your significance level, you're going to compare it to your p-value. And so for the first one, your alpha is, or your significance level is 0.05. So if you're comparing that to the 0.0276 that the p-value is, the p-value is going to be less than the significance level. So the sample result is statistically significant at 5% level. So we would say, since the p-value 0.0276 is less than the significance level, .05, the sample result is statistically significant at the 5% . So this means we have sufficient evidence to reject the null hypothesis and conclude that the company's deluxe AAA batteries last longer than 30 hours. Alright, so when we reject the null hypothesis, what that means is we basically turn to the alternative hypothesis and say that we think that that's true. For B, now our significance level, or our alpha, is going to be 0.01. And so our 0.01 is going to be smaller than our p-value. So what we do in this case is we say, since the p-value is greater than the significance level, the sample result is not statistically significant at the 1% level. We do not have enough evidence to reject the null hypothesis in this case. Therefore, we cannot conclude that the deluxe AAA batteries last longer than 30 hours on average. So next we're going to talk about error in significance tests. So you have two types of error. You have type 1 and you have type 2. So type 1 is if we reject the null hypothesis when the null hypothesis is true, and type 2 error is if we fail to reject the null hypothesis when the null hypothesis is false. So down here is kind of a little table that might be helpful for you. So if we reject the null hypothesis when the null hypothesis is true, we have a type 1 error. And if we reject the null hypothesis and the null hypothesis is false, or the alternative is true, then we have a correct conclusion. If we fail to reject the null hypothesis, so basically we're saying that we agree with that, and the null hypothesis is true, then we have a correct conclusion. So that's good. But if we fail to reject the null hypothesis and the null hypothesis is false, so basically we agree with the null hypothesis even though it's false, and the alternative is true, then we have a type 2 error. So this is going to be very important, and I would refer back to this as often as possible and commit this to memory. So an example with type 1 and type 2 errors. So a potato chip producer and its main supplier agree that each shipment of potatoes must meet certain quality standards. If the producer determines that more than 8% of the potatoes in the shipment have blemishes, the truck will be sent away to get another load of potatoes from their supplier. Otherwise, the entire truckload will be used to make potato chips. To make the decision, a supervisor will inspect a random sample of potatoes from the shipment. The producer will then perform a significance test using the following hypotheses. So the null hypothesis is when P is equal to 0.08. So the p-value is 0.08. The alternative hypothesis is when the p-value is greater than 0.08, where P is the actual proportion of potatoes with blemishes in a given truckload. So we're going to describe what a type 1 and a type 2 error in this setting would be and the consequences of each. So if we think about a type 1 error means that we reject the null hypothesis when the null hypothesis is true. So basically we say that we do not think that the proportion of potatoes with blemishes in a truckload is 0.08, even though that's true. So, for type 1, the best way to describe that would be the producer concludes that the proportion of potatoes with blemishes is greater than 0.08. So we rejected the null hypothesis. We said we think it's greater than 0.08. When the actual proportion is 0.08, or it could be less. So we said we think that the proportion with blemishes is greater than 0.08. However, in actuality, it is either 0.08 or it's less. The consequence of this would be the potato chip producer sends the truckload of acceptable potatoes away. And this, of course, could lead to loss of revenue. For the supplier. All right, let's talk about type 2. So type 2 error would be when we fail to reject the null hypothesis. So we say the null hypothesis is true, even though it's actually false. And so for this one, we would say the producer does not send away or does not send, let's say, the truck away when more than 8% or the 0.08 is a proportion of the potatoes in the shipment have blemishes. The consequence for this would be that the producer uses the truckload of potatoes to make potato chips, and that would mean that more chips would be produced with blemishes, which may upset customers. So type 2 in this case would be if you were eating a bag of chips and you got that nasty chip that looked like it was like a big hunk of dirt or like it was cooked too long. And so that would be an example in this case of like type 2. All right, so check your understanding. A company has developed a new deluxe AAA battery that is supposed to last longer than its regular AAA battery. However, these new batteries are more expensive to produce, so the company would like to be convinced that they do last longer. Based on your years of experience, the company knows that its regular AAA batteries last for 30 hours of continuous use on average. The company selects a simple random sample of 15 new batteries and uses them continuously until they are completely drained. A significance test is performed using the hypotheses that the null hypothesis is the mean is equal to 30 hours and the alternative hypothesis is the mean is greater than 30 hours. Where the mean is the true mean lifetime of the new deluxe AAA batteries, the resulting p-value is 0.0276. For number 1, we have to describe type 1 error in this setting. So remember that type 1 means that we reject the null hypothesis even though the null hypothesis is true. So in this case, for type 1, we would conclude that the new batteries last longer than 30 hours when, in fact, their average lifetime is equal to 30 hours. Two, to describe a type 2 error in this setting. So with a type 2 error, remember that that means that you are failing to reject the null hypothesis. So you're basically saying that the null hypothesis is true even though the null hypothesis is actually false. So then for 2, we would conclude that the new batteries do not last longer than 30 hours when in fact they do last longer than 30 hours. And then 3 is which type of error is more serious in this case, justify your answer. So really that's just going to kind of depend on what you think. One possible answer that you might say is that you might say a type 1 error you think is worse, and you might say that that's worse because the company would be wasting its money producing a new battery that won't really be any better than the old battery was. So significance in type 1 errors. Significance level alpha of any fixed level test is the probability of a type 1 error. That is, the alpha is the probability that the test will reject the null hypothesis when the null hypothesis is in fact true. Consider the consequences of a type 1 error before choosing a significance level. So next we're going to talk about power. So the power is the probability that the test will reject the null hypothesis at a chosen significance level alpha when the specified alternative value of the parameter is true. So the power of a test against any alternative is 1 minus the probability of a type 2 error for that alternative. That is, the power is equal to 1 minus beta, beta being the probability of type 2 error for that alternative.